This is Math 2, 8.4 notes. That's Unit 8, Lesson 4. The title is Simplify Exponential Expressions. We are first going to start off with fill in the blanks. Number 1, x to the fourth times x to the blank equals x to the sixth. X to what power would make this work? X to the fourth times x to what power equals x to the sixth. We know at this point we're going to add exponents. So pretty much you're asking yourself 4 plus what is 6? And the answer is 2. I'm going to lightly put in there, if there were a 2 there, 4 plus 2 is 6. That would be your answer. Okay, next one. Number 2, x to the 13th times x to the blank equals x to the 5th power. Okay, well, I'm hoping you recognize that the number has to be negative because 13 plus a positive is never going to equal 5. So 13 plus what negative equals 5. If it helps you, you can make an equation. I wouldn't use x since there's already x there. 13 plus negative 8 is indeed 5. Okay. Number 3, x to the blank times x to the 5th equals 1. I'd like you to hit pause and try this one on your own. Like, what is this going to be that's going to make my answer 1? Okay. I'm hoping you tried it on your own. If you did and you are still struggling, I'll give you a hint. 1 is equivalent to x to the 0. So try it on your own now. X to the 0 is 1. What does this exponent have to be so that when you add them together you end up with x to the 0? It is negative 5. I've had kids give me negative 6, negative 4, 0. Negative 5 is the actual answer. Negative 5 plus 5 is 0, and next to the 0 is indeed 1. Okay, next piece, find the value of x. Number 1. 5th root of 7 to the 3rd power times 7 to the 1/5 power equals 7 to the x over 5 power. Okay, so we want to solve this equation. We want to find the value of x. First off, recognize that they're all the same base, which is good. So I'm going to rewrite this side so I can add exponents. In order to add exponents, the bases have to be the same, which they are. So I'm actually going to rewrite this one in exponential form. So 7 to the 5/3 or 3/5. It is 3/5. And 1/5 is just going to stay because it is already in exponential form. And then we have done this before. You add multiplying like bases. 3/5 plus 1/5 is 4/5. 7 to the 4/5 equals 7 to the x/5. The 7s are the same, the 5s are the same. What does x have to be so it equals this original problem? X must equal 4. X to the 4/5, 7 raised to the 4/5 would equal 7 raised to the 4/5. All right, let's try another one. And you do have plenty of these on the test. Number 2, 5 raised to the 4/3 over the 6th root of 5 squared equals 5 to the x power. That should be a 5. Equals 5 to the x power. All right, so we're going to rewrite the left side, and on the left side I'm going to rewrite the denominator because that's the one that's in radical form, and I want to change it to be exponential form so I can combine the exponents. 5 to the 4/3, I'm going to leave that one the same, over 5 to the 2/6. Now remember here I don't add the exponents, I subtract. And the reason we subtract is because we're dividing like bases. Okay, so I'm going to do that here. 4/3 take away 2/6, finding a common denominator. Or you can reduce the 2/6, that's up to you. I'm just going to find a common denominator. 6 is going to stay -2. And here I'm going to multiply top and bottom by 2. 4 times 2 is 8, 3 times 2 is 6. Now their common denominator, 8 and -2 is 6 over 6, which reduces to 1. Sometimes we reduce, sometimes we do not. Let's see on this one if we're going to want to. 5 raised to the 6 over 6 equals 5 raised to the x. X is just x, it's not a fraction, so I am going to reduce it. 5 to the first power equals 5 to the x power, therefore x is 1. All right, moving along, we're going to simplify number 1. A versus B, and we've talked about this one before. Parentheses 3x to the -2nd power versus 3x to the -2nd power. We've talked about this in class. What's the difference? Is there a difference? There indeed is. Here we distribute the -2 to both of them. What powers are here that we don't see? They both have a power of 1, and I don't do -2 times 3. I do -2 times the power of 1. So it's 3 to the -2nd and x to the -2nd. And they both have negative exponents, so they both move. 1 over 3 squared times x squared. And 3 squared can be simplified, so 1 over 9x squared is the final answer. Versus this one here, only the x is being raised to the negative, so it is the only thing that moves. The 3 does not. 3 stays put, 3 over x squared, and you are done. Notice the difference. The parentheses does make a difference. You want to make sure you understand that for quizzes and tests. Okay, number 2. Parentheses. 2y squared, close parentheses, 4th power, over parentheses 6y, close parentheses, squared. Okay, so I have parentheses with big power, so I am going to distribute. I'm going to go ahead and put my 1's in. I need a 1 there, a 1 there, and a 1 there. And since they are, it's not one big parentheses, I'm going to distribute the 4 only at the top and the 2 only at the bottom. Okay, so I end up with 4 times 1, not 4 times 2. So 2 raised to the 4th power, y raised to the 8th power, over 6 is going to stay 6, and I do 2 times 1 is 2. Y is going to stay y, and 2 times 1 is 2. I'm going to simplify. 2 to the 4th power is 16. 6 squared is 36. Y to the 8th, y squared. Now I am going to simplify. I'm hoping you recognize that I can subtract these exponents here because there's more at the top than there is at the bottom. Once I subtract, the y's will end up at the top. 8 take away 2 is 6, so y to the 6th at the top. What do I do with these numbers here? The biggest mistake kids make, no matter how many times I say it and I say it and I say it before the test, kids still make this mistake. They subtract these. I do subtract exponents, that is correct, but 16 and 36 are not exponents, they're coefficients. This piece here you simply reduce, just like you were taught back in elementary school. What divides into 16 and also divides into 36? 4. 16 divided by 4 is 4. 36 divided by 4 is 9. So 4y to the 6th over 9 is the final answer. Okay, number 3. 6xy to the negative 3 over negative 2, x to the negative 2, y to the negative 1. You do have plenty of these on the test as well. What you do here first, before doing any adding or subtracting of exponents, is move your negative exponents. Move them around. If they're at the top, move them down. If they're at the bottom, move them up. Now, remember, -2 is not a negative exponent. That is a negative coefficient. This is a negative exponent. This is a negative exponent, and even that there has a negative exponent. -2 is not a negative exponent. It's a negative number, a negative coefficient. So it is staying put. So I'm going to leave it there for now. 6, -2. This x at the top, the x to the first, because it's positive, it's staying put. And this x to the -2 is going to join it. So I have x to the 1, x to the +2 now because it moved. These two exponents on the y's are both negative, so they're pretty much going to switch spots. Y to the positive first at the top and y to the positive third at the bottom. Do you see how that worked? X's joined X's because this one was positive and this was negative. Because the y's both had negatives, they pretty much just switched spots. Okay, so sometimes both variables move, sometimes none, sometimes only one. You just have to be careful. All right, this here, we do not subtract, we reduce. Reduce, reduce, reduce the big numbers in the front. 6 divided by -2 is -3. Here we add the exponents. That gives me x to the third. And here I subtract. I don't want to do 1 take away 3 because that's negative. So I'm going to do 3 take away 1 is 2. And because there's more at the bottom, the y squared is going to be at the bottom. That is the final answer. Okay. We do have a number 4 and a number 5 that we're going to do together in class. So you want to make sure you leave space there and get them done in class. That is it for this lesson.